Hello, Professor. This is my project for the week 16, which is the array project from last week, but converted into using functions. Uh, well, we use the Irvine library again for this one, so we can use some prompts from last week. I finally got it like color coded or highlighted. That's why it's acting up, and most of these words are underlined. I wasn't able to fix that, but let's start off with the main procedure, which is here. I didn't really change too much from the beginning of the procedure. Pretty much we ask for user input for the amount of elements that they want to make the array. We validate the input, and once it's good, we take EAX and we save it into count. From there, we continue down, and our first call is to array entry. And this array, this function also has the entry validation nested inside. It's going to call it from array entry. So let's go to that one. Which is here. So for array entry, procedure uses ECX, ESI, and EDX. And what this uses is going to push and pop these registers. And it's basically the same from the last project. When I did the array project, I kind of fixed it in a modular way that it was easy for me to just translate them into functions, pretty much just put them into blocks and then just label them with the procedure. Right here, we use the ECX as a counter. We started with 1, then we loop around. Well, we prompt them first for the elements, then we use another prompt to ask for the individual elements, and from there we call the other function, entry validation, which takes us to this one here. Entry validation, which uses EDX and it pushes and pops it with uses. And this is where we validate the elements. And from here, if it's a good integer, comes down here and it tests it for whether it's negative or not. And if it's negative, then it comes back to retry, bumps it back to element, and back and forth like that. If the first element is good, then it returns back to here to array entry and continues. So once you get a good element, you save it into ESI, and then we switch the location to the next element within the array. We increment ECX, and then we compare it to count. And if it's not equal, if it's not greater, then we keep on looping. Once they're equal, compared to less than or equal, if yes is to count. Yeah, once it's greater than, I guess, it exits this procedure and continues on to the next, goes back to main procedure. Main procedure, then we call array sort. And this is the array sort right here, which pretty much just sorts the array. We use the uses, we use EBX, ECX, ESI, which pops and pushes and pops the release registers. We use count, and we use 2 loops, an outer loop and an inner loop, to loop through the arrays and sort them from in ascending order. After it's done with the 2 with all the loops. It exits the procedure and returns back to main. For main procedure, we call print array. In print array, the name says it all. It's just going to print the array that's organized already in ascending order. And we separate them with commas. Once it's done printing, well, this one uses ECX, ESI, and EDX. So with the uses, we push and pop the registers. After it's done printing, it goes back to main again. Finally, it calls calculate the sum, which is this right here, which actually calculates the gaps in between each element, prints out the gaps, and on top of that, it calculates the sum of the gaps. So like in the last project, I print a new line, then we print the gaps R prom, and then we subtract one from each. We subtract one from count because we're going to use count to compare it to ECX. And we go through the loop. We calculate we move the first element into EBX, and then we move the second element to EAX. We subtract them, and then we save that into a sum. We save the difference into sum, and then we move the counter location. We move the location to the next one. We reset the registers. We increment ECX. We compare ECX to count, and then we add the commas. From the comma, we jump back again to calculate the next gap. And then we sum it up. We print out sum to show the sum of the gaps. After this is done, it returns to the main procedure. After the main, it just exits. After it comes back to main, it exits, and then it ends the program. So let's run the code just to check it. We're going to use the suggested input from the array project just to make sure that it's still working. Here it is. We use -15, gives us a wrong entry. Try again. We use a 5. Then the first element was a 9, a 0. We just put a T in there, invalid integer. So then we do a 2, a 10, and a 5. And there you have it. The sorted array is 0, 2, 5, 9, and 10. The gaps are 2, 3, 4, and 1. And the sum is 10. So this is my project for the week. And that's it. Thank you. I'll see you in class, Professor.